the SIVIA algorithm is an algorithm which makes it possible to solve the set inversion problem using interval analysis. SIVIA means set inversion via interval analysis. I have a function f and a known set y. And I want to compute the reciprocal image x of y by f. This set is uncertain. It is the one I want to compute. And I will approximate it by two subpaving x minus x plus, which bracket the solution set x. I will consider different situations. The first situation is, let me consider one box inside the solution set. Of course, I don't know yet it is inside. The image of this box is something like this, and by the inclusion function f, I will obtain a box like this. Since the resulting box is inside y, I know, because of this inclusion test, I know that this box will belong to x. So it means that if f of x is a subset of y as here, then x is inside x, and I will store this box into x minus, but also into x plus. Another situation, consider a box which is outside x. Its inclusion function may be like this, like this. It is an image by f, this one is an image by the inclusion function. And since this box is outside y, I can conclude, thanks to this inclusion test, that this box is outside x. So if f of x does not intersect y, then I will not store it neither in x minus, neither in x plus. So I discard it. Discard x. I will consider another situation. I consider a box like this, which is neither inside x, neither outside. Its image could be like this, and by the inclusion function, I will obtain something like this. So, this box does not satisfy this condition nor this condition. In such a case, I will bisect it into two subboxes. So, if these conditions are not satisfied, else what I will do, I will bisect the box into two boxes, x1 and x2. This is x1, this is x2. And I will store x1 and x2 inside a list of boxes. I will now explain what means this list of boxes. You can imagine that I will have a paving, so many boxes, and I will have to store all these intermediate boxes inside the list. Of course, what happened? I will bisect these boxes. I will have at the beginning a list L, which will be initialized with a single box x0, which is huge. It can be, for instance, x0. This huge box will not satisfy this condition, neither this condition. It will be bisected. And after I will generate two boxes that will be bisected and so on. And I will quickly obtain a situation where I will have small boxes that are on the frontier of X. In such a case, what happens? The image of this one is small, I cannot conclude anything, and I will have to stop bisecting, otherwise my algorithm will never terminate. So in such a case, if the width of X is smaller than a small number, say epsilon, then I will store this box not in X minus, but in X plus. Then store X into X plus. So now I will have to do this while the list is not empty, then I will pull a box, the current box, from L, and I will have to perform all these operations. Of course, when the list becomes empty, my algorithm will terminate.